Take two, welcome back. We're going to look at the mechanics of the indefinite integral. Indefinite means it doesn't go from one place to the other. It just, when we take the indefinite integral, it gives us an equation that describes the area, but doesn't actually give us a set number. So no interval, we're just finding the equation. Ching. They say f of x is the integral, is the area under the curve f of x. F of x is the integral under the curve f of x. So if you take the integral of f of x dx, right, the dx is the width, it's sort of notation in there, you get the f of x, the integral, and they put this plus c at the end. That's always got to be there. If you take the integral, it gives you the line above it. The only problem is we don't know if that line is here or if it's here. It doesn't give you this c value at the end, because when we differentiate this, it goes away. Right? So based on the area underneath, I can't tell what that is at all. I have no idea. So we know it could be something. There could be something there. It might be 0, but it could be something, and likely it will have a constant at the end. So this constant plus c reminds you that, oh, there's something in there. There could be something at the end. We don't see this if we take the integral. You'll never get a constant sitting at the end waving at you, right? So we have to understand that it could be there. It's likely there, and there are ways to find it. But just taking the integral like we're going to do, or like we've done in the past, doesn't necessarily show us what that is. So right now we're going to leave it as c. Cool. So here's some rules for integration. They're in your formula booklet. Might be worth writing it down though. If you differentiate, for integration. If you integrate just a constant, you get the constant times the x value. It's sort of like integrating this guy that we were doing, constant value. Yeah. This is the trick that we just showed you, that I just showed you, right? You increase the exponent by 1, and then you multiply by the reciprocal of that new one. So this whole thing you could think of as 1 over n plus 1 times x to the n plus 1. Oh yeah, and also constant c could be there, right? This one is the big one. So let me get it out of your way so you can see it. This, remember when we differentiated e to the x, you got e to the x. This is the same way, but going that way, plus c. Same thing when we differentiated natural logs. You got 1 over x. This is the same thing backwards. When you differentiated sine, you got cosine. This is backwards. And the same sort of thing, but they switch the negatives on there. There's no product or quotient rule. So sometimes you have to multiply and divide before you integrate. Okay, so let's try a couple of these. I'm going to differentiate this and do it piece by piece. So this came from x to the 4th, and let's put its reciprocal in front, the new exponent's reciprocal in front. So the 4 and the 1/4 multiply to this 1 that's assumed in front, and then we decrease this, so I like that. This came from x cubed. The 2 is there, but you don't see the cubed in front, so that comes because we had a 1/3. Right, so the 3 times the 1/3 canceled out, and you're just left with this 2, and then this 3 dropped to the 2. This 5 was 5x, right? And the x went away, and you got just the 5. Oh, and also there could have been a constant. Right? When you clean this up, it cleans up to this, right? Here's the 1/4. Here's the 2/3, and here's the 5x plus c. Great. It doesn't really matter how you leave this, just clean it up a little bit. This is the same sort of thing, but make this prettier first. Make it exponential form. So here's the -3, here's the 1/2. All right. This piece, the -3, this is a tricky one. These get bigger, right? The exponents increase in size. So you're going from 3 up to 2 if they're negative. You're getting less negative, it's getting bigger. And that's a little fussy to see sometimes. So here's my x to the -2, and here's 1 over that. And then same sort of thing, this piece, this half is getting 1 bigger, 3/2, and then multiply by the reciprocal, 1 over 3/2. Now, I'd probably run that like this. This one I'd call x to the -2, and then I multiply in front 1 over -2, leave it for now. This you'd call x to the increase this by 1 3/2, and multiply by the reciprocal, 2/3. This is obnoxious. And plus c, great. And then you clean it up, and I think probably they cleaned it up nicely. Yeah, neat. You can kind of leave it in whatever form unless they oblige you one way or the other. Okay, so sometimes we got to find that c value, right? And they have to give us a point to find the c value. So this is using the particular values to find c. Here's an example. They say, I want to find the original function given that when we took the derivative, we got this. Okay, fine. So that means we have to take the antiderivative or the integral to get back here. So we take this, the derivative. To get the original function, we take the antiderivative, which means take the integral. It means the integral of all of that. Nice, thanks. I know for this first chunk, the exponent's going to get bigger by 1, so x to the 4th, and here's the reciprocal 1 over 4 being multiplied by it. And the same game happens for all this. So this is going to become 3. We have to multiply by the reciprocal, so 1/3. So that's where we get this 2/3. And then this 3 came from 3x, right? And there could have been some constant that was, when we took the derivative, kind of went away, right? So like if you took the derivative, if this was 8, and you took the derivative and went from here to here, the 8 would go away, right? You don't see the derivative there. The 3x turns into the 3, and the constants disappear, essentially. So here's our f of x. They tell us f of 0 is 2. Well, great. So then if f of 0 is 2, we can plug in zeros to all the x's, right? Put in 0 and 0 and 0. And I know I should get 2 out, right? Plug in 2 for that. Oh, maybe they did that for me. And so this will be 0 to the 4th is 0 divided by 4, so that's where this 0 comes from. 0 cubed times 2, 0 divided by 3 is 0, that's where this comes from. And this is 0 plus c gives us 2, and so therefore we can solve and say, hey, c is 2. Hence, there we go. Plus 2 at the end. We can only do that if they've given us this constant, right? So if we wanted to, if we graphed this f of x, right? If we graph this f of x, where's my graph? Here's that graph all laid out. Looks like this, and it doesn't hit the point we want. That point we want is right there. This 0, 2, right? So it doesn't hit that point. So we have to add the c value to drag it up into 0, 2, right? This is the equation of this line, and the this function is going to be the slope at any point, right? Because it's the derivative. All right, so let's try a couple more just to make sure you're comfy with it. If we want to integrate this, this is one of the ones that this is sort of like the chain rule. We'd have to, the sneaky trick is that we need to multiply this apart first. So first of all, square this. So 3x plus 2 over x times itself. FOIL or binomial multiplication, whatever you want to call it. And we get this, and now we're in business. Maybe we want to change this around so it looks a little different like that, and then we can start integrating in pieces. So this will increase by 1, go to 3 to make sure that it's canceling out. You got to put 1/3, the reciprocal of this new exponent, and so that's where this piece comes from. The 12 came from 12x. Nothing more needed there. And then this, the same thing. Be careful because this is a -2. We got to make it more positive, so it becomes -1. We do the reciprocal of -1, which is 1 over -1, and also plus our c value because we could have some constant that has been derived out. Clean this up, and it looks like 3x, the 12x is happily sitting there, and then this negative makes this negative, and this -1 gives you the fraction plus c. Neat. All right, let's try one last one. Here they're giving us a chance to find the c value. This is not the c value, but it's how we find it. They said find f of x given that the derivative was this. So you took the derivative to get here, so you're going to have to take the integral, the antiderivative, to get back. All right, let's change this around a little bit. This is going to be x to the 1/2, so I think that's probably where they started. F of x is going to be the integral, the antiderivative of this derivative. And that's fine. So we're going to take the integral of each piece, and let's start with this one. This is sort of like saying we took something, some f of x, and when we took the derivative of it, we ended up with 2 sine x. Right? Well, this piece should be negative cosine x, because if you took negative cosine x with a 2 in front, negative cosine x, the derivative of cosine of x is negative sine x, so this would be 2 times negative, and the derivative of this is negative sine x. The two negatives get together and give you that positive that's implied in front, and so I think that's where this piece comes from. And then this part, gotta get your colors straight, Borkevich. This part, you increase the exponent by 1, so 3/2, and then multiply by the reciprocal out in front. This is the reciprocal. I don't love this notation. I would probably write it like this, where you go, I know it's x to the 3/2. There's nothing sitting, there's a implied 1 in front of there, so you're multiplying by the reciprocal 2/3. Dividing by the fraction flips the fraction, so this divided by 3/2 is the same as times 2/3. I like my notation better. Great, there's that. And then when you clean it up, it should look like that. My notation. Plus the c, don't forget the c, man. All right, so we found the equation for it, but we can find the c value because they told us if you plug in x, we should get out y. So plug in x and get out y. So you can say all of this should equal 4 if I put 0 in here and 0 in here. And so cosine is 0, cosine is 1 at 0, right? Cosine is distance out, 0 is there, so cosine is 0, this should be 1. So -2 minus 0 plus c is 4, so add 2 to both sides, so that's where they get the 6 from. Cool? And thus, they plug 6 into this c value, and that's where they get that. Whew. That's it.